In this video, I'm going to talk about the symbolic constants. There are a few ways to define a constant in assembly language. You can use equal sign, you can use EQU keyword directive, or you can use test equal directive. This is the easiest way to define a constant. You just give your constant identifier, then use equal sign. And this is a constant count equal 500. Then you can use your constant in your coding. And for example, here you can copy whatever is in count into register AX. How to calculate the size of an array? In last video, we talked about arrays, different ways to make an array. Here we have example. The array name is list. The array type is byte. You have 10, 20, 30, 40 in the array. So the array size is 4. These numbers are in decimal format because you don't see H or B at the end as radix. To calculate the array size, we have to do it this way. And you can have a constant name for a valid identifier. Use equal sign. Then parentheses. You use $sign minus the array name. This will give you the array size if it's a byte array. The $sign marks the end of the array address. The list name is the beginning address of your array. So you use array's ending address, that's the $sign, minus the beginning address. This gives you how many bytes total use in your list storage. So this is the array size because each of this is a byte. So you subtract the ending address minus the beginning address, you get the total bytes. That should be the array size for a byte array. So here we have a constant. It's called list size. Okay. Here we have a word array. Word is another data type used in assembly language. It's 16 bits, that's 2 bytes. So here we have list as the array name. The data type for each this element is word, 2 bytes. And we have 4 hexadecimal numbers here. To calculate the array size, we're going to use a constant variable list size equal, use ending address of this array minus the beginning address of this array, then divided by 2. The ending address minus the beginning address only give you how many bytes used totally by your list. Since each one uses 2 bytes because the size is word, so we have to divide by 2. And we get the size for this array. For this one, we can see it's size 4. Okay. Next, we have another example. The array is a Doubleword array. List is the name. Doubleword is the array type, storage type, or data type. And it means each of these is going to use 4 bytes for the storage. To calculate this array size, we say list size equal ending address, use $sign minus the beginning address, that's the list name, then divided by 4. This will give you the total used bytes by this array. You divide it by 4, you give this is going to give you size 4 because each of this number will use 4 bytes. So you have to divide it by 4 to get the real size for the list. Now continue with the constant directive, and we use EQU. This is a keyword. Here we have an example. Suppose you want to divide by pi. Pi is a constant you use to calculate a circle's area or circumference. So you can say pi equal, then put a constant 3.14 or 16 inside the bracket. Also use EQU directive, you can define a string constant. You say the constant name is press key, then put your constant in here. This is a string, so you double quote your string constant, and your string end with a null character. That's the end of your string. When you define data, when you want to use this constant to initialize your variable, you can do it this way. You say your variable name is a prompt, is a byte for each their storage, and use constant press key to initialize the prompt. Test equal constant directive. This is the third way to make a constant. Here you say you have a constant string continue message. Use keyword test equal, then put do you wish to continue inside the bracket. Here you have another constant row set equal 5. When you declare your variable under the data segment, you can use this constant strings. You say your prompt 1 is byte, initialize it with a continue message. That means it's going to be like this. Okay. Then you're going to initialize a variable count, and you say is test equal use row size multiplied by 2. So computer is going to evaluate this expression and use the value, the result here to initialize the count. Here, one more example, set up error, and you're going to use test equal, and you're going to say the setup error means move count into error. So in the coding area, you can just say setup error. This equals exactly move error with count. Okay. The book mentioned a little bit 64-bit programming. Is just about knowledge. If you are interested, you can read about 64-bit programming. So the basic template structure is like the same as our template for 32-bit programming. You need a title, you need an exit prototype, your data segment, your code segment, your main procedure, and your end. Here you don't say main and the end. It's a little bit different. This keyword is different. You are not required to do 64-bit programming, so this is just knowledge. So this is a continuation for 64-bit programming. That's the end of this chapter. Here I'm going to continue with Visual Studio. I'm going to show you more the programming side. Okay, let me end this show. I'm going to open my Visual Studio, the project space. So I'm going to open my hard drive C, and you need to do the same when you do your program, because the Urban folder installed under hard drive C. Open my Urban folder, open examples folder, then I'm going to use the project sample folder. The built-in workspace is inside this folder. So after getting into this folder, I'm going to open the configuration file for the project. This is going to run my Visual Studio. So I'm using Visual Studio 2012. You may have 2015, 2017. That should be working no matter which version you are using. I have students in the class that are using 2017 that download the Urban's examples, libraries, everything's fine. So you have to try out. So it's open already. Let me open. You can see this is what I have did in last video. I made two strings, my message, my name. String can end with 0DH, 0AH. If you use 2 0DH, 0AH, once for ending line, once for blank line. Okay, 0 means null character. This marks the end of your string. So this is the variables I declared. You can have different kind of variables, byte, sign byte, word, sign word. In my coding segment, in my main procedure, I call clear screen, so this cleared my screen first. Then I have print a message. To print a message out in assembly in this course, we're going to use Evans library function. The library function is called write string. You use the keyword call to call this function. Before you call write string, you have to set up EDX with the address of your string. If you want to print my message, you have to say move the offset of my message into EDX. So for any string you want to print out, you have to bring the offset of the string into register EDX. Here I have another example. I want to print out my name. I bring the address of my name into EDX. Then I call write string. Last video I also show you how to use dump register these library functions. I'm going to suppose I want to see V1 on my output screen. I can move V1 into the lowest byte of UAS register. So before I use UAS register, I set up UAS to be 0. I want to clean up UAS before I use it. So AR is the lowest byte UAS. V1 is a byte, so you have to move a byte to a byte. You have to match their size, otherwise you're going to cause error. So I dump register so I can check error values on the screen. Okay. Second, I'm trying to print out a V3 variable. V3 is a word, 2 bytes, 16 bits. So I had to use register EBX. So I use EBX with 0 clean up. Then I copy V3 into BX. BX is half of EBX. V3 is a word, so BX is a word. That matches the size. So then you can call dump register. So that's what I did in last video. Let me run this quickly to see the result again. So you can see I have two strings. The first one is defining data. Second one is nickel gel. Then I have first dump register, and I should see A1 AL. The value is 10. A means hexadecimal 10. That's right. In my second dump registers, that's this area. I use EBS. I'm going to check a BX value. This is EBS. I need to check the lower half. So BS is, I think it's 200 something. C8 should match whatever you declare in that section. So that's how you check to verify your outputs. Today I'm going to add more to this program. Suppose I want to declare an array of lists. I can say a list is a byte. I want to know the list. Let me call this one list 1. This one. Suppose I want to initialize with 1, 2, 3, 4, 5. I can continue. That's enough for me. So I'm going to calculate the list 1 size. So list 1 size equals you're going to use end $sign minus the beginning your list. That's list 1. The list name always the address the beginning of your array. So this is how you calculate so let me do a little comment here. So you need to have habit to do comment. So this one get byte array size. So that's my list 1. Let me continue with list 2. I'm going to make list 2. List 2, I'm going to use 2 byte, that's word. Let me initialize with 10, 20, 30, 40, 50, 60. Okay. I'm going to calculate list 2 size. So list 2, the array size use equal sign, and list 2 size will be $sign minus list 2, and that's the beginning address. Ending address minus beginning address, then divided by 2. Because each this use 2 bytes, you divide by 2, you get how many you have here. So that's the second one. For my third example, I can use a double word 4 bytes for the array. So here, let me just copy to modify it. So this is going to be my list 3, and this is going to be my list 3. Okay, minus list 3. The beginning address. This one needed to divide by 4 because this is okay. Let me try to copy this over here. So for important statements, you do comments, get word array size. Okay, this one is for get double word array size. So this one I need to divide by 4. This one is a double word array. Each of this element use 4 bytes for storage. So beginning minus ending minus beginning give you total bytes. Then divided by 4 tell you how many you have here. Let me add one more to here. Okay. Okay. Now let me run. Oh, something wrong here. Let me check. Okay, let me see, I may have typo in my code. Okay, divided by 1, 2, 3, 4. Oh, here, I don't know. Let me try to, oh, okay, this is list 3, okay, this is list 2. Divided by 2. Let me just try 1 to see. Sometimes you cannot add too many at one time. You may have mistake. It's very hard to debug in assembly. This is a low-level language, and when you click your debugger area output, you don't get much information why you have the mistake. So you have to be careful. And it won't show you any typos, any grammars. It's hard to debug, just say that. Okay, let me see what I put here. What's wrong with here? Okay, let me try again. Okay, that means my this line got oh, okay. I see. I have a mistake. This is not a list 1. This is a list 1 size. Sorry, I cannot do it. List 1 is the array name, so this one is the list 1 size. So this is hard to find out the typo. List 2 size. I use a constant variable. So here, this is list 2 size, not a list 3. So now I know this is what happened to me. So I'm going to take away my comments to rerun my code. Okay, here, erase. Let me build. Oh, it's fine. Everything is fine. Let me show you how to print out the array size out. I can just use my register. You can use EAX, EBS, ECS, ED. Okay, general registers. So let me try to print. Suppose I want to print the list 3 size out on my screen. I can. For right now, we can just use dump registers library function. There are some other functions we can use in the Irvine library, but they are going to be covered in later chapters. Right now, I don't want to introduce them. So I can just say move. Okay, let me use move statement. Let me move like EAX. Okay, EAX with the first constant, that's list 1 size. Or let me do list 3. List 3 size. Copy list 3 size into EAX. Then I can call dump register. Dump regs. Okay. List 3 size is 8. So I should have 8 hexadecimal 8 for this dump register in the EAX. Let me build. Okay, it's okay. So I'm going to run. Okay, let me check my last registers in EAX is 8, so it's fine. It means our calculations for every size is working, and our dump registers code is working. So you want to verify any other registers value, you just bring them like list 1 size, list 2 size into the registers. Then you can use them. Okay, thank you for watching this video.